Hey, all you cool cats and kittens. Time for another lesson of Algebra 1. Sorry, I had to. I hope you understand that reference. If you don't understand that reference, you might actually be better off. Hope everyone's doing pretty good out there, keeping yourself safe. Let's do another lesson on Algebra 1 called Completing the Square. 9.5, Completing the Square. So if you look at this problem we're going to start off with, it asks us to solve the following quadratic equation. If you recall, solving means to set y equal to 0. We are finding the values of x that make y equal 0. The only way we know how to solve thus far is by factoring. So we'd ask ourselves the question, what multiplies to 3 but adds to 6? That's the question we need to ask ourselves. So the answer to that is nothing. The only thing that multiplies to 3 is 1 times 3. But 1 plus 3 is 4, not 6. So this doesn't factor. So there is absolutely no way to solve this by factoring if it doesn't factor. So therefore we must have another way to solve this, if indeed this has a solution. So let's go back a little ways, and we're going to solve this thing by graphing it. We're going to first check, does it actually even have a solution? Oh, not 6x squared, x squared plus 6, x plus 3. X squared plus 6x plus 3. We're going to graph it, and we're going to see, does it actually even have a solution? So if you recall, you take negative your b value divided by 2 times your a value. Our b value is 6. Our a value is 1. So we have negative 6 divided by 2 times 1. Negative 6 divided by 2 times 1 is negative 3. So the x value of our vertex is negative 3. Create our xy table. We're going to put negative 3 in the middle of our xy table. We're going to go to the right 3 places, negative 2, negative 1, and 0. We're going to go to the left, negative 4, negative 5, negative 6. We're going to plug in the x value of our vertex. This is our vertex. This is where we're going to be symmetric. So we plug negative 3 in. Y equals negative 3 quantity squared plus 6 times negative 3 plus 3. Negative 3 squared is 9. 6 times negative 3 is negative 18 plus 3. 9 minus 18 is negative 9 plus 3 is negative 6. Now we're going to plug in negative 2. Y equals negative 2 quantity squared plus 6 times negative 2 plus 3. 6 times negative 2 to negative 2 squared is 4 minus 12 plus 3. 4 minus 12 plus 3 is negative 5. Since we're symmetric, since this is negative 5, negative 4 will also yield negative 5. We plug in negative 1. Negative 1 squared plus 6 times negative 1 plus 3. Negative 1 squared is 1 minus 6 plus 3 is negative 2. Plug in 0. Easiest of all to plug in. When I plug 0 in, x squared goes to 0. 6 times x is 0, so it's 0 plus 0 plus 3, which is just 3. So we now go over to our graph, and we're going to graph this. We start at negative 3, negative 6, so negative 3, negative 6. We put our vertex. This parabola is going to open up. We are also here and here. We are at negative 1, negative 2. That means we're also at negative 5, negative 2. We are also at 0, 3. We're also at negative 6, positive 3. And just as I've always said, you need to go off the graph. 1 is going to give us 10. And negative 7 will also give us 10. So here's our parabola. connect all your dots with the smoothest curve you can. Remember your arrows before it goes up forever. Now here, these are our solutions. If you remember, the solution is where the parabola crosses the x-axis. We cross the x-axis here, and we cross the x-axis here. But the problem is these values, they are not what we call integers. They are not whole numbers, as some of you like to say. They happen somewhere between -6 and -5, and it happens somewhere between -1 and 0, which makes it very difficult to solve it precisely by graphing. And as we already saw up above, this thing does not solve by factoring because it's not factorable. So how are we going to solve something that is not factorable and we can't find the solution graphically or the precise solution graphically? Introduce completing the square. Now, this is a very, very powerful lesson. Completing the square is extremely important. It is the only method we have learned so far that you can use on every single quadratic. So we start with the question, x squared plus 6x plus 3 equals 0. What can I plug in for x that makes this whole thing equal 0? As I've already said, nothing multiplies to 3 but adds to 6. You cannot factor it. So we're going to learn how to do completing the square. You subtract your constant to the right side. But when you do that, you're going to add a blank on this side. And whatever you do to one side, you must also do to the other side. So the statement is called completing the square. We are going to turn this entity on the left-hand side into a perfect square that is factorable by adding in a value here. But to not change the equation, we have to add it here, and we also have to add it to the other side. So how do we get a value here that makes this whole thing a perfect square? This is the step of completing the square. You take your b value, you divide it by 2, and then you square it. In our case, the b value is 6. So we're going to take 6, divide 6 by 2, and then square that. 6 divided by 2 is 3. 3 squared is 9. So the value that we're going to place here is 9. We're going to put a 9 in that blank, and we're going to put a 9 in this blank. By putting it in both sides, we've kept the statement the same. But look over here. If you remember our factoring perfect squares, ding, 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 9 is a perfect square, x squared is a perfect square. What multiplies by itself to equal 9? Well, the answer is 3 and 3. But what's 3 plus 3? Well, that's 6. So this thing factors. The things that multiply to 9 but adds to 6 is 3 and 3. So this is a perfect square. So we have now factored it to a perfect square. X plus 3 squared equals -3 plus 9 is 6. Now we're going to finish this by taking the square root. When you take the square root, do not forget your plus and your minus. The square root undoes the square, leaving just x plus 3. On the other side, we have plus minus the square root of 6. We can now subtract 3, getting our two solutions, -3 plus and minus the square root of 6, which really means that x equals -3 plus the square root of 6, which is about, if you plug it into your calculator, -0.5505. 5. And we also have x equaling negative 3 minus the square root of 6, which is about negative 5.4495. Now, if we compare these values with what we got up here, that makes sense. We said it's somewhere between negative 6 and negative 5, and it's somewhere between negative 1 and 0. Well, lo and behold, these values match with our graph above. So let's continue practicing this. Flip your paper to the other side, and we've got ourselves some practice problems. Replace y with 0. At the same time, I'm also going to flip it over. So I'm going to set the equation equal to 0. X squared minus 4x plus 6 equals 0. You subtract your constant to the right-hand side. When you do that, you add a blank to both sides of the equation. What gets placed inside of this blank is going to be the thing that completes the square. How do I complete the square? Well, you take your b value, which in this case is negative 4. You divide it by 2, and you square it. Don't forget that this is a negative 4. It's important that that's a negative. Negative 4 divided by 2 is negative 2. But negative 2 squared is positive 4. So a positive 4 gets placed in the blanks. Now we have to look over at this side. Again, we completed the square. This has now become a perfect square. What multiplies to 4 but adds to negative 4? The answer is negative 2 and another negative 2. But x minus 2 times x minus 2, that's a square. So we can write this as x minus 2 squared. What does this x minus 2 squared equal? Well, it equals negative 6 plus 4, which is negative 2. I solve this by taking the square root. When you take the square root, you don't forget the plus and the minus that goes in front of the square root sign. Uh-oh, we are taking the square root of a negative value. That is what we call not real. So the answer to this is no real solutions. The reason it's no real solutions is because this is the square root of a negative. Now, we could say the non-real solutions are, the non-real solutions are that x equals, add the 2 over, 2 plus minus the square root of negative 2. But that is not going to ever be the answer for our class. The purpose of our class, this would be your answer. No real solutions. Let's try again. This time we don't have a set equal to 0. We have a set equal to 8. That's okay. I still add 12 over, and I'm going to add that 12 to the 8, getting x squared minus 8x plus blank equals 20 plus blank. What gets placed in the blanks? Well, we take our b value, which is negative 8. You take negative 8, you divide it by 2, and you square it. Negative 8 divided by 2 is negative 4. But negative 4 squared is positive 16. That's why this is a plus here. This will always be a plus, because when you square a negative, you get a positive. So a positive 16 goes in both the blanks. What multiplies to 16 but adds to negative 8? The answer will always be here. What did I square to get positive 16? I squared negative 4. So it is x minus 4 squared. Negative 4 times negative 4 is 16. But negative 4 plus negative 4 is negative 8. This is a perfect square that becomes this statement right here. Let's look at the right-hand side. 20 plus 16 is 36. Finish this by taking the square root. Don't forget your plus and your minus. The square root cancels out the square, leaving us with just x minus 4. But wait, this is a perfect square over here. We have the square root of 36. The square root of 36 is 6, with a plus and minus in front of it. So I have two answers. Add 4, and you have 4 plus 6, and another answer, which would be 4 minus 6. 4 plus 6 is 10. 4 minus 6 is negative 2. Your two answers are positive 10 and negative 2. Now I want to look at this one again. This one worked out perfectly. We have two integers here. What does that mean that this came out to be integers? Well, it means that from the very beginning, we could have solved this by factoring. You have x squared minus 8x minus 12 equals 8. We could solve this by factoring, by subtracting the 8 over and setting it equal to 0. And we have that x squared minus 8x minus 20 equals 0. Now I'd ask myself the question, what multiplies to negative 20 but adds to negative 8? The answer would be negative 10 and positive 2. Now that I have my two factors, I take my two factors and I set them equal to 0 separately. Add 10, and I get one answer is 10. Subtract 2, and I get another answer is negative 2. Lo and behold, the exact same answers that we got by completing the square. Positive 10 and negative 2. Positive 10 and negative 2. The only reason why we could do this one by factoring is because, well, the original statement is factorable. But the only way to find out if a statement is factorable is by checking if it factors. Completing the square, this step right here of completing the square, brings us to the answer without having to check whether it does or does not factor. Let's try another one. X squared plus 10x minus 15 equals 5. Add 15. X squared plus 10x plus blank equals 20 plus blank. What gets placed in the blank? You take your 10, you divide it by 2, and you square it. 10 divided by 2 is 5. 5 squared is 25. 25 gets placed in both blanks. Now, on this side, it is a perfect square. What multiplies to 25 but adds to 10? 5 and 5. So it factors to x plus 5 squared equals 20 plus 25 is 45. Take the square root. Take the square root. Don't forget your plus and your minus. X plus 5 now equals the plus minus square root of 45. Subtract 5, subtract 5. You get your two answers. X equals negative 5 plus the square root of 45. And you get another answer, negative 5 minus the square root of 45. Now if you plug those into your calculator and check what they equal, you get two statements that x is approximately negative 5 plus the square root of 45 is 1.708, and negative 5 minus the square root of 45 is negative 11.708. Your two approximate answers. Your 2 exact answers. Try one more. This one's a little bit trickier. I'm going to move around the statements. I'm going to move this equals 6 to the other side. So I have 3x squared plus 15x minus 6 equals 6. I'm going to add my constant over 6 plus 6 is 12. But there's something different going on in this one. If you look back on all the other ones we have had so far, our coefficient of our quadratic term was 1. Our coefficient of the quadratic term was 1. Our coefficient of the quadratic term was 1. Now the coefficient of the quadratic term is 3. How do I deal with the 3? Well, you have to divide that 3 out. You must divide every single statement by 3. So 3x squared divided by 3 is just x squared plus 5x plus blank equals 4 plus blank. What gets placed in the blank? Well, again, we take half of our b value. Uh-oh, this time our b value is odd. So I have to take 5, divide it by 2, and then square it. When you square a fraction, all you have to do is square the top number and square the bottom number. So 5 squared is 25, 2 squared is 4. So the thing that gets added into both blanks is 25 over 4. Now, go here. What did I square to get this? I squared 5 halves. So, what gets placed in this spot here is always going to be what you squared to get this 25 fourths, which is 5 halves. And 4 plus 25 fourths is 41 over 4. Take the square root. Take the square root. Don't forget your plus and your minus. Just like I squared a fraction by squaring the top and the bottom, I can square root a fraction by square rooting the top number and square rooting the bottom number. So I have the square cancel out the square root, leaving just x plus 5 over 2 equals plus and minus the square root of only 41 now, and the square root of 4 is 2. So recognize that I purposefully am dividing this, but the square root does no longer include the denominator. Subtract over 5 halves, and you will recognize that this has a denominator of 2, this has a denominator of 2. They have a common denominator. So x is going to equal -5 plus and minus the square root of 41 with a common denominator of 2. Now be very careful when you type this into your calculator. If you're going to type that into your calculator in one step, you must put the top in parentheses. You must put this in parentheses if you're going to do it in one step. Otherwise, do it in 2 steps. You'll get 2 answers that x is about 0.702 and -5.702. All right, one last problem, the word problem. This is the exact same type of word problem that we dealt with in the previous lesson. We have a box. This box has a distance around it, but we don't know one of the distances. The distance from here to here is x. The distance from here to here is also x. This distance here is x. This distance is 1, and this distance is 1. So how do I take a distance of 1 with a distance of x, with a distance of x, with a distance of x, with a distance of 1? Well, you add all of these distances together, getting 1, 2, 3x plus 2. So the length from here to here is 3x plus 2. The width is the exact same idea, except that the width is just, this is x, and this is 1, and this is 1. So I have a width that is 1x plus 2 ones, which is 2. So I take the length times the width equal to the area of 100. Length times width equals 100. Length is 3x plus 2. The width is x plus 2. Double distribute. 3x times x is 3x squared. 3x times 2 is 6x. 2 times x is 2x. 2 times 2 is 4. Combine my like terms. 3x squared plus 8x plus 4 equals 100. Subtract my 4. 3x squared plus 8x equals 96. Again, we have a leading quadratic coefficient that is not 1. You must make this equal 1 by dividing everything by 3. Then I get that x squared plus 8/3 x plus blank equals 96 divided by 3 is 32 plus blank. What gets placed in the blanks? Well, it is half of your b value. Our b value is 8 divided by 3. So I need to take 8 divided by 3 and take half of it. Taking half of something is the exact same thing as multiplying it by 1/2. And then you square that. Well, half of 8 is 4/3. 4/3 squared, square the top, square the bottom, 16 divided by 9. What did I multiply to get the 16 over 9? I multiplied 4/3. So this becomes x plus 4/3 squared equals, and 32 plus 16 over 9 is 304 over 9. Take the square root. Don't forget your plus and minus. You can square root the bottom, which is 9, which becomes 3. It has a common denominator of 3. So you get the statement that x plus 4/3 equals plus and minus the square root of 304 over 3. Subtract over 4/3, and you get, let me get my papers here situated. I'm going to have to move them up underneath this guy. You get that x equals -4 added and subtracted with 304, and that's all divided by 3. Now again, if you're going to plug this into your calculator, you must put the top in parentheses, but you will find that one of these answers is going to be negative. When you take -4 and you subtract 304, you're going to get a negative answer, which doesn't make sense in the context of our problem. So the only answer is the positive answer, which is -4 plus the square root of 304 over 3. So when you plug that in, you get 4.48 feet. And that is how you complete the square. I know it looks like a lot. I hope you followed along with me. You can rewatch this video as many times as you need. Please reach out to me if you have any questions. There will be available, probably already is, 9.5 completing the square. It is the most powerful tool that we have to solve quadratics. You can always use it. There is never a time when you can't complete the square. It's an extremely important thing to know now, and also in the future we're going to use it a lot. So please check Math Excel online, and stay safe and sane. See you guys.